What's going on, everyone? Today's deep dive is all about Russia's sovereign internet and the future of mobile proxies. What to expect. I'm going to walk you through everything step by step, so by the end of this, you'll have a really solid understanding. Let's go. Russia has been quietly building one of the most ambitious internet control projects in the world, and most people in the proxy industry are not paying attention until it directly affects their workflow. The Sovereign Internet Law, sometimes called RUNET, is a multi-year effort by the Russian government to gain technical control over what enters and leaves the country's IP space. It involves deep packet inspection at the network edge, blocking lists maintained by Roskomnadzor, mandatory routing rules for Russian ISPs, and increasingly aggressive treatment of VPNs and proxies. If you operate mobile proxies or if you rely on Russian IPs for any kind of research or access, the next few years are going to reshape what is possible. In this guide, I will break down what the sovereign internet actually is, why it matters for mobile proxies, what has already changed, what is coming next, and how operators and users should think about adapting. Let's start with the background. Russia passed the Sovereign Internet Law back in 2019, and the rollout has been incremental ever since. The technical core of the law is a system known as TSPU, which stands for Technical Means of Countering Threats. TSPU boxes are installed at the major internet exchange points and at the network edges of Russian telecom operators. These boxes can inspect traffic, block specific protocols and domains, throttle services, and redirect traffic. They are operated centrally by Roskomnadzor, the federal telecom regulator. The stated goal is to allow Russia to disconnect from the global internet in the event of an external attack, but in practice the system has been used for everyday censorship, throttling, and access control. Using mobile proxies in Russia, when they exist, operate on top of the major cellular carriers like MTS, Beeline, Megaphone, Tele2, and Yoda. These carriers route traffic through TSPU infrastructure like any other ISP. That means a mobile proxy in Russia is not the same as a mobile proxy in Singapore or the United States. It sits behind a national filter that can selectively block specific destinations. This has real consequences for anyone trying to use Russian mobile IPs for testing, research, or geospecific work. Some destinations work fine, others are blocked entirely, and the list changes with political conditions on a weekly basis. Why does this matter to you? If you are doing market research targeting the Russian audience, you need to actually see what Russian users see. That means having access to IPs inside Russia on real consumer connections with the same filtering applied. If you are auditing your own brand's geo-availability, you need to verify that your site loads from Russian residential and mobile IPs, because international users on VPNs see something different than locals on filtered connections do. If you are running compliance checks for a global service, you need to know which features the Russian filter is currently breaking. And if you are an operator running mobile proxy infrastructure, the sovereign internet directly affects your ability to source SIMs, your routing options, and your legal exposure. Let's talk about what has already changed. Over the last few years, Russia has dramatically tightened its handling of VPNs. The federal block list now covers most popular consumer VPN providers and their server IPs. App stores have been pressured to remove VPN apps for Russian users. Protocols associated with VPNs, including OpenVPN, WireGuard, and IKEvo2, have been throttled or outright blocked on TSPU. Even obfuscated protocols like ShadowSox and V2Ray are detected and shaped down to near zero bandwidth on many cellular paths. Mobile proxy operators inside Russia have had to adapt by using less common protocols, by rotating ports, and by keeping a much lower profile than they used to. The cat-and-mouse game is intensified. Mobile proxies have a slight advantage over standard VPNs in this environment. A mobile proxy on a real cellular SIM looks like any other mobile user from the network's perspective. The IP address is shared with thousands of other phones on carrier-grade NAT. The proxy traffic, if you keep it inside HTTPS, looks similar enough to normal phone browsing that it can blend in. But this only works if the proxy software does not advertise itself. SOX 5 on standard ports gets flagged. MT Proto over its default port gets recognized. Operators have moved toward custom proxy protocols, port hopping, and CDN fronting just to stay viable. This is a constant operational burden that does not exist in less restricted geos than one is UTRA action. The first is full whitelist routing for certain services, which would invert the current model. Instead of blocking specific destinations, the network would only allow approved ones, and everything else would default to blocked. This has been piloted on specific holidays and during periods of political tension. If it goes permanent, proxy operators in Russia would face a wall higher than anything we have seen so far. The second is mandatory inspection of all encrypted traffic, which would require either certificate manipulation, downgrade attacks, or active man-in-the-middle, all of which break basic web compatibility. The third is tighter control on SIM card sales, including biometric registration, which would make it harder for operators to acquire SIMs in bulk for proxy farms. The fourth is cross-border data localization rules, which would force any company doing business in Russia to keep user data on Russian servers. increasing legal exposure for anyone running proxies cross-border. None of these are guaranteed to happen on a specific timeline, but the direction of travel is clear. For mobile proxy operators outside Russia, the implications are more subtle but still important. Russian users are increasingly leaving Russian route services and using offshore proxies and VPNs to access the wider internet. Demand for non-Russian mobile IPs from inside Russia has grown. At the same time, Russian banks, payment processors, and identity verification systems flag offshore IPs more aggressively. So if you are running a service that needs to verify Russian users, you have to balance access against fraud signals. There is also a reputational and legal question for proxy operators who knowingly serve Russian users circumventing the filter. Depending on your jurisdiction, this may or may not be a problem, but it is a question that did not exist in the same form a few years ago. Now let me get into the practical step-by-step of how to think about this. Step 1 is to map your dependencies. Identify which of your workflows touch Russian IPs, either as a target or as a source. This includes scraping, research, ad verification, brand monitoring, customer support, and identity checks. Step 2 is to test your current access for multiple Russian network paths. Use both residential and mobile proxies if you can source them, and document what works and what fails. Things that fail today may have failed yesterday too, but you will not know unless you actually test. Step 3 is to set up monitoring. Build automated checks that hit your critical destinations from Russian IPs on a daily basis. When something starts failing, you want to know within hours, not weeks. Step 4 is to diversify your sources. If you depend on a single mobile proxy provider in Russia, you have a single point of failure. Cultivate relationships with 2 or 3 providers and accept that any one of them may go dark. Step 5 is to plan for the worst case. Have a fallback for what happens if Russian mobile proxies become unviable. That might mean using residential VPNs, partnering with on-the-ground researchers, or simply accepting that some workflows are no longer feasible. The cost of pretending nothing will change is higher than the cost of preparation. For users who just need access to Russian content from outside, the calculus is also shifting. Free proxy lists for Russia are mostly junk. They get blocked within hours by Roskomnadzor's automated systems. Paid residential proxies have been more reliable but are not immune to bulk blocking when a provider's IP ranges get flagged. The most reliable option in 2026 is still a small number of legitimate mobile proxies, but the cost is rising as supply shrinks and operator overhead grows. Expect prices to keep climbing. Let me talk about pitfalls. The first one is assuming that Russian proxies behave like proxies anywhere else. They do not. Filtering is applied unevenly across carriers, regions, and time. The second pitfall is testing once and assuming results hold. They do not. Test continuously and treat any successful access as time-limited. The third pitfall is bringing political assumptions to technical decisions. The filter does not care about your opinion, it cares about heuristics. Engineer accordingly. The fourth pitfall is putting all your proxy budget into Russian IPs when most of your traffic does not actually need them. For many workflows, a single Russian IP for occasional verification is enough, and the bulk of your budget belongs elsewhere. The fifth pitfall is ignoring the legal landscape. Both Russian law and your home country's law may impose requirements on how you handle traffic to and from Russia. Get advice that fits your specific situation before scaling anything. Real-world examples bring this to life. A brand monitoring company used to run continuous checks from Russian mobile IPs to verify that their clients' ads were being served correctly. They had to migrate to a mix of mobile and residential, with 2 providers, and a fallback plan that ships them a small device hosted on a Russian retail connection. A scraping team that focused on Russian classifieds saw their success rate drop from over 90% to under 50% over 2 years. They rewrote their scraper to be more patient, with sticky mobile sessions and randomized request timing, and got back to about 70%. A travel pricing aggregator gave up on direct Russian access entirely and partnered with a local research firm who provides verified screenshots and snapshots on demand. None of these solutions are pretty, but they are what works in the current environment. Let me go deeper into the technical architecture of the sovereign internet, because understanding how it actually works changes how you plan around it. The TSPU boxes are not single devices. They are clusters of inspection and filtering hardware deployed across the major peering points and at the borders of carrier networks. Each box performs line rate deep packet inspection on traffic flowing through it. The inspection logic combines static block lists, protocol fingerprinting, and increasingly machine learning models that flag suspicious patterns. The boxes are centrally managed by Roskomnadzor, which can push new rules within minutes to all deployed units. This is what makes the system so responsive to new circumvention tools. When a new protocol or tool gains traction, Roskomnadzor can update the filter and have it deployed across the country in under an hour. The TSPU system also performs throttling rather than just blocking. Throttling is the more sophisticated weapon because it does not announce its presence. Users see slow speeds and assume their connection is bad. They may not even realize that a filter is intentionally slowing them down. Throttling has been used against Twitter, Facebook, and various VPN protocols. The throttle can be partial, affecting only large file downloads while leaving short text requests alone, or it can be total, choking the connection until it times out. For proxy operators, throttling is harder to diagnose than blocking, and it shifts the user experience from broken to merely frustrating. Carrier-grade NAT is another piece of the puzzle. Russian mobile carriers use CGNAT extensively, which means a single public IP is shared by thousands of mobile users. This affects mobile proxy operators in two ways. First, the IPs naturally have high reputation, because banning one would block thousands of real users. Second, the upstream connectivity from CGNAT pools passes through TSPU before reaching the global internet, so the filtering applies to mobile traffic just as it does to fixed-line traffic. The mobile IP reputation advantage is partially offset by the filtering disadvantage. Operators have to weigh these against each other. For mobile proxy operators in Russia, the operational picture has shifted significantly. SIM acquisition used to be simple and cash-based. Now it requires passport registration in most cases, and there are quotas on how many SIMs a single person can register. Some carriers maintain stricter compliance than others. Bulk SIM acquisition through corporate channels is harder than it used to be, and the paperwork is intensive. Proxy operators have either consolidated with larger commercial entities or operated in informal gray markets. Both have risks. The commercial entities face regulatory exposure. The gray market faces enforcement risk. On the routing side, operators have moved toward custom protocols and CDN fronting to keep traffic flowing. CDN fronting means putting your proxy traffic behind a major CDN, like Cloudflare or Akamai, so the network observer sees a connection to a popular CDN endpoint rather than to your proxy. The CDN then forwards traffic to your backend. This pattern has been quietly successful, though some CDNs are themselves being pressured to drop fronting customers. Custom protocols mean abandoning standard SOC 5, OpenVPN, and even MT-Proto in favor of bespoke obfuscation that is not on any DPI signature list. These work until they become popular enough to attract a signature, at which point they get added to the block lists and the cycle starts again. Let me also dig into what this means for users outside Russia who interact with Russian audiences. If you run a service that has Russian users, several things are changing. First, your CDN may have less reliable delivery into Russia because the CDN itself may be inconsistently routed. Second, your authentication providers, like Google, Facebook, or Apple, may have variable availability depending on TSPU conditions. Third, your fraud detection signals may be unreliable because the same user may appear with very different network characteristics from one session to the next as their circumvention tool switches paths. Build for resilience. Cache aggressively. Allow alternative authentication methods. Treat Russian traffic as a special case in your monitoring. Well, let me cover a few more pitfalls. Pitfall 6 is treating one provider's success as a general signal. Some operators have lucky relationships with specific carriers or specific routes that work for them, but not for others. Cross-verify with multiple sources before assuming a setup is generally reliable. Pitfall 7 is using metrics from outside Russia to evaluate Russian access. A latency check from London tells you nothing about how Russian users experience your service. You need probes inside Russia. Pitfall 8 is forgetting about IPv6. Russia has been pushing IPv6 adoption, and some filtering applies differently to v6 traffic. Test both protocols. Pitfall 9 is over-reliance on any single circumvention tool. The tool that works today may be the next target. Diversify. Pitfall 10 is ignoring the human side. Russian users are increasingly skilled at navigating filters, and your support team should be ready to help them with proxy and VPN troubleshooting if your service requires reliable access. Let me give a few more real-world examples that illustrate the constant change. A SaaS company serving Russian SMBs had stable mobile proxy access through a particular Singapore-based provider. Over 6 months, the success rate dropped from 95% to 60% without any obvious reason. They investigated and found that one of the Russian carriers their probes used had quietly tightened its routing, while the others had stayed the same. They split their probes across multiple carriers and adjusted their alerting thresholds accordingly. A research team studying Russian classifieds rebuilt their entire scraping pipeline to be carrier-aware, running parallel jobs on 3 different carrier pools, and merging results, with automatic failover when any single carrier dropped below a success threshold. A media company that depended on Russian audience analytics partnered with an on-the-ground research team in a neighboring country who has reliable cross-border routing and can run periodic verification on demand. None of these are pretty. All of them are what the environment requires. There is also a positive example. A small Russian-speaking community channel outside the country built a self-hosted MT-Proto proxy on a cheap VPS in a friendly country and shared it with their community. 3 years later, the proxy is still running. The traffic patterns are normal enough that it has flown under the radar. The lesson is that not everything is hopeless. Small, well-managed setups with discipline can persist for years, even in a hostile environment. Let me also address a few frequently asked questions. Are mobile proxies in Russia legal? The short answer is that the operation of mobile proxies is not specifically illegal, but the regulatory environment around SIM cards, hosting, and circumvention tools is complex and evolving. Many operators function in gray zones. Users typically face no legal risk from using a mobile proxy for normal purposes, but operators may face heightened scrutiny if their service is associated with content that is restricted. Treat the legal landscape as evolving and consult appropriate counsel for any business-scale operation. Should I run my proxy infrastructure inside Russia or outside? The answer depends on your goals. For research on Russian internet behavior, you need IPs inside Russia. For circumvention of Russian filtering, you need IPs outside. For most use cases, you actually need both, used for different purposes. How often should I rotate IPs? For circumvention, plan to rotate hosting IPs every few months, even if everything seems fine, because preemptive rotation often beats reactive recovery. For research from inside Russia, sticky sessions matter more than rotation. What about Telegram-specific traffic? Telegram in Russia is its own discipline, with MT-Proto and fake TLS being the dominant tools. We have a dedicated guide on using Telegram in Russia that covers the specifics. There is also a question of long-term direction. The trend in Russia is toward more centralized control, not less. Even if individual blocking events come and go, the underlying capability of TSPU continues to grow. Plan for a future where the average level of filtering is higher than today and where specific tools may become harder to use over time. The operators and users who adapt fastest are the ones who build redundancy into their setups, who stay informed through community channels, and who do not depend on any single tool or technique. Alright, that is everything for today on Russia's sovereign internet and the future of mobile proxies. We covered the background, the technical architecture, what has already changed, what is coming next, and how to plan for it. If you want to go deeper on mobile proxy infrastructure, sticky session design, and cross-border proxy strategy, head over to dataresearchtools.com for our full library of guides. Until next time, take care and stay adaptable.